So today we're looking at data distributions again. We'll use the distribution or shape of these data sets to interpret the data and compare it to other data sets. The thing about shape is that it looks a little wonkadoo with a box and whisker plot, so it gets its own day. We're going to start by talking about what we know about box and whisker plots. So here in the middle of my box plot is my center or my median. So that's my middle value. And I know that half of the data falls below the median, and I know half falls above. Okay, further, I know that here at my quartile 3, I have 1/4 above that and 1/4 below that. Above, below. I don't know if I said that right. And down here at my first quartile, I'll have 1/4 below and 1/4 above. So our quartiles, quartile 1, the median, quartile 3, they chop our data into fourths. Okay, so that's what you need to remember about box plots. Now we're going to talk about shape. So when you're looking for shape, you need two things. The first thing you need is the lump, where your data is concentrated. The second thing you need is the tail, because the tail is going to tell you which way it's skewed. Okay, so when I look at these over here on the far left, I see 1/4, 1/4, 1/4, 1/4. It's really weird because this looks big over here, but it's not actually a lot of data over there. That data is really spread out. That data is like Wyoming or Montana. Wyoming. Okay, it's like mostly bison and tumbleweeds. That's a lot of room, but there's not a lot of data over there. On the other hand, over here, I've got the same amount of data, but it's packed in tight. This is like concentrated, like population, like New York, where everyone's packed in like sardines. Okay, so what you need to realize is that even though the left side of this looks big, you actually have a higher concentration of data over on the right-hand side. So this one has a lump on the right and a tail over here on the left on the Wyoming side. So this one is actually skewed left. Skewed left. Okay. The one below it, it's the same thing. It just looks a little different. We have the lump and the tail. Same thing, skewed left. Just a variation. Let's look at the other side, the other far side. On this side, we see 1/4, 1/4, 1/4, 1/4. We see how it's flip-flopped. All of our data is packed in on this side, that's the lump, and the tail is on the right. So this one is skewed right. Okay, and so is the one below it. We got a lump, we got a tail, skewed right. The only one we haven't talked about is the very middle one that we sort of marked up with some vocab. That one, you can see that it kind of is a mirror image of itself. Like if you fold it on the median, everything would land on itself. So that one is our symmetric one. You can kind of imagine a belly shape over it. Okay, this one is symmetric or bell-shaped. You could also call it normal. Normal. Okay. See, they all look a little strange, but you'll get the hang of it. All right, we've got Karen's homework scores. So if we're trying to figure out what shape we have here, we see 1/4 of Karen's scores are below her first quartile. 1/4 right here, 1/4 here, and 1/4 here. We can tell that the lump is there and the tail is on the left. So this has to be skewed left. All right, next, which of these is true? Well, I know that if we're talking about the median is this right here, and I can see that that's at 90. All right, what they're trying to trick you into doing is saying that it's at 80 because it looks like that might be in the middle, but we know that that's not right. So it would have to be that the median is 90. They're also trying to get you to pick the mean because you forgot your vocab, but you're not going to forget your vocab. You're going to remember. Okay. What percent of the scores are above 95? So if we look at above 95, that's 1/4 of the data. And if you put that in your calculator, 1 divided by 4, you're going to get 0.25, which is 25%. True or false? Half of Karen's scores are below 80. They're trying to trick you again. We know that half of the scores are above 90, not 80. So that's false. All right, the interquartile range is basically IQR is going to be the top of the box, the quartile 3, minus, let me use a different color, minus the bottom of the box, which is quartile 1. So quartile 3, that looks like 95. Quartile 1, that looks like 80. So I've got 95 minus 80. My IQR is 15. Now we have 2 box plots showing funds donated to 2 different charities. Be careful because this is thousands of dollars, not regular dollars. So now we're going to find the interquartile range for charity A. So same thing, top of the box minus the bottom of the box. So that looks like 40 minus 28. So you can check on your calculator, but I'm going to call that 12. I'm going to call that 12. That was 40 minus 28. The median is the center right there. That looks like 36 to me. The range is the max minus the min. So the max for A looks like 48. The minimum looks like 16. 48 minus 16, 32. And the shape for charity A. Ooh, let's look at that. You could make a case for the data lump being over here and then a tail over on the left. So I would say that that's probably slightly skewed left. Skewed left. All right, now we're going to do the same thing for B. So the IQR is the top of the box, 40 minus the bottom of the box. So that's 40 minus 24. I'm getting 16. The median is just this center. Now be careful because it's halfway in between 28 and 32. So to me, that's like 30, right? That's a tricky one. Be careful. The range, again, is just the maximum value minus the minimum value. So I'm seeing 52 minus 20, which should just be 32 again. Interesting. This is what I'm seeing. Look at that. All right, more on that later. All right, describe the shape for Charity B. Well, it's pretty much the opposite, isn't it? We have a lump over here on the left, and the tail is on the right. So if the tail's on the right, it's skewed right. Skewed right. All right, if we're trying to figure out who got more money, which is more useful, the interquartile range or the median? Now, the median is like a middle value, right? Middle value. So it's kind of one of our measures of central tendency. The interquartile range doesn't tell us where the center of our data is at all. If I look at the interquartile range, Charity B has a bigger interquartile range. But that's not why they're getting more money. Charity A actually has a higher median than Charity B. So I would say that the median is more useful because it's like the average. It's more like the average. I mean, the average is the mean, but the mean, median, mode are measures of central tendency, and they tell us about the middle of our data set. That's what I mean. Okay, if you need to determine which charity received more money, which is more useful, the spread or the shape? Now, the spread is just another name for the range. Why is this not writing? Sorry, technical difficulties. Range. Okay, the spread is the range. Oop, I'm not circling that. I'm just saying that that's what it is. Spread is range. Okay, now, if I'm looking at these ranges, they're the same. That's why I circled that. Look at this. Those ranges are the same. So it's not telling you anything about who's getting more money because the ranges are the same. So we have to say that the shape is telling us more about who's getting more money. Look at Charity A compared to Charity B. You can tell that Charity A got more money. All right. Shape. I am circling shape. All right, I would say Charity A. The average is higher. The lump is higher. A lot of people donated smaller amounts to Charity B, and a lot of people donated higher amounts to Charity A. So we're going to say A.